myself. I'll just, I think that if I share the screen here, we should be able to see this. So I want to start right off with my contact information in case folks have interesting thoughts that want to share with me after the presentation or questions that come up. You're certainly welcome to email me at any time. As John mentioned, this is the second time around for me. I did one a couple weeks ago, and I was interested in sort of separating the solar stories out in the systems that I have here. And this is one of my favorite systems because it's my very first one that I worked on. And you'll see as we go through here that some of it is not real modern, but I guess that's okay. This is a picture of the system that I'm going to talk about tonight. It's a relatively simple system, just 4 small 65-watt panels that feed the electricity into my little utility shed here. And in my utility shed, I keep a variety of yard tools that are now all rechargeable electric. My wife and I really appreciate and enjoy the electric yard tools that we have, and I'll talk a little bit more about them later because I'm excited about the applications of solar as well as the solar itself. So some parts of this system were originally purchased and installed back in 2003. So I've been working at this for a little while here. The solar panels are almost that old. They're a little bit younger than that. But I purchased them back when solar panels were expensive. These 4 small 65-watt panels cost, I unfortunately couldn't find the original invoice. My wife and I looked for it and we couldn't find it. So I don't know exactly what they cost, but I think it was about 4 or 5 times as much as solar panels are going for now per watt. So it was an expensive proposition back then to put up these even 4 small panels. So it made some sense at the time, economically, to put them on a tracking mount. The tracking mount keeps them pointed right at the sun, which provides a substantial increase in power output. And besides that, it was just fun. The tracking mount is just fun to work with and fun to watch. And I can describe a little bit more about how that works here. This is the tracking mount when it first wakes up in the morning. I have some trees shading it early morning, but about 10, maybe 11 o'clock or so, late morning, it wakes up and it tips into the sun. The way it works is on either side of the tracking mount, which is made by ZoneWorks, there is a black tube that has an outer aluminum shield on it. And so there's a differential heating of the tube that's on this side compared to the tube that's on this side of the mount. And there's a simple fluid-filled tube between them. And the differential heating causes the fluid to transfer from one side of the panel array to the other, and it tips into the sun to keep the 2 outside tubes here matched in temperature. And as I say, it's fun to watch. It works remarkably well. It's slow enough that you can't see it move unless you're really patient. But it works. After just a few minutes of being in the sun, the panels are pointed straight at the sun. It tracks accurately all the way over till it's shaded again in the afternoon, late afternoon, 4 or 5 o'clock, and then it goes to sleep for the night, and it looks like this, tipped all the way over on the other side. So, as I mentioned, I did this primarily for help production and to have something fun to play with. But I'm not recommending solar trackers now. Panels are so cheap that if I were doing this over again, I'd just buy 1 panel and put it on the shed roof and be done with it. It's a significant extra effort to get this up and to get it pointed south and to get it all counterbalanced properly so that it works real smoothly. The back of the panels look like this. The ZoneWorks mount itself is very simple. It's just a simple frame the panels screw to, and there you can see one of the tubes on the other side of this array. Electricity, this is a very simple system. All 4 panels feed into a single combiner box that sends 12 volts over into the shed. And I do have this system very well grounded and with a lightning arrestor to prevent surges from damaging this equipment. And these are all just going to get in parallel. So they're 12 volt panels and they stay at 12 volt. Again, modern panels are higher voltage and operate differently, but this is a very, very straightforward system that seemed expensive at the time, but has certainly been worth it over the years for the power it's produced for our tools. So the power, I'll just follow the path of the power here just to describe what happens. The power goes into this charge controller. This is a very old charge controller. It's kind of primitive by modern standards, but it does have this little readout that gives me some idea of what's going on. You can see I've got a couple thousand amp hours since I first plugged this back in. I don't remember when I last had the system down for maintenance, but it produces power, and right now the batteries you can see are at 13.8 volts, so they're fully charged. And although it's a simple old charge controller, it's robust, and these things just keep operating. If I were to get a charge controller now, it would be a much more modern one that provides a significant boost in output, but I'll describe that a little bit more later. From the charge controller, the electricity goes down into my batteries. There's actually 2 sets of batteries here. The ones on the top are the power tool batteries that I'll talk about in a few minutes after I describe the solar system. These are all made by the Eagle Corporation, and they're different sizes for different pieces of yard tools that I have. They all fit all the yard tools, so you can use anything you want to, but the big one here, for example, is kind of heavy for the weed trimmer, but it's great for the lawnmower. But down below here are the 4 deep cycle batteries that I use to store the electricity from the solar system. They're just big 12 volt batteries I bought at Sam's Club. They're getting pretty old now, getting kind of long in the tooth. They're about 8 years old, so I'm guessing I'll need to think about replacing them here pretty soon. But they're just good old lead acid deep cycle batteries sitting there doing their work. This is an unconditioned shed, so they get cold in the winter and hot in the summer. But lead acid batteries are tough, and they can take that. I don't use the system very much in the summer, with one exception that I'll mention in a minute. But from the batteries, the electricity goes up into the inverter. This is a sine wave inverter. This is the oldest part of the system. This comes back way from 2003, so it's 17 years old now. And the inverter takes the DC power from the batteries and changes it into AC power that's usable by the implements and the battery chargers. All modern inverters of this size have the outlets right on them, so you can plug your appliance or whatever you want to right into the inverter. But this is an old hardwire model that has to be plugged into or connected to a separate circuit breaker panel over here with outlets mounted below it. So this is an older system that you would not have to work with if you were going to do this yourself. You could just plug whatever you wanted to right into your inverter. This is a little fuse box over here with standard fuses in it to protect from, well, any kind of over voltage, both input and output to the inverter. And then I do have another lightning arrestor over here on the AC side, as well as a ground fault and arc fault interrupter circuit breaker for safety's sake and to protect equipment that's plugged in here. Since what I have plugged in here total is worth protecting with some equipment. So again, relatively simple charge controller, inverter, AC output with batteries in between that store the power. So the power is used for our lawn tools, yard tools. We made an initial investment in Ego lawnmower, thanks to my sister who bought one and just loved it. So we bought one too. You can't have your sister do something that you don't do. So I nabbed a lawnmower. And once we had invested in the Ego system, we continued to expand Ego systems, and we bought a chainsaw that's powered by the same kind of battery, and a trimmer that's, again, the same kind of battery, and then a snowblower. So we use these for everything that we do. We have no gas-powered equipment anymore that we have to mess with, which is just wonderful in the spring to just have everything just work. You just put on the battery and go. Of these tools, my favorite is the chainsaw. I had no idea how nice it is to not have an angry, stinky little two-cycle engine whining at you when you're doing chainsaw work. This is just wonderful to have a quiet electric motor running a chainsaw, and Ego does a great job with their chainsaw. It's a powerful little chainsaw, 16-inch blade that has done everything I've asked it to. And I do have multiple batteries from these other pieces of equipment that I can put in here, but what I found is that the battery that came with it is just perfect for me, because right when the battery runs out, I run out, and then I recharge both myself and the battery, and I'm good to go. The snowblower is a single-stage snowblower. It's not a superpower snowblower. I wouldn't be able to do heavy, deep, wet snow with it. But for 90% of the snow that we have here, actually more than that, the snow that we have here in this part of Michigan, it's great. It works really well. It clears the snow well, and it's quiet and very easy to use. And then we also fairly recently bought a riding mower that's electric. This one is so much fun to use that my wife and I have little fights over who gets to mow the lawn next. It's like a little go-kart zooming around the lawn. It's just really fun, very quiet. There's the hum of the blades that can get a little noisy if you're cutting wet, heavy grass, but normally they're just sitting there quietly spinning away. And we also charge this with the solar system, but it does not take those same batteries. It has its own batteries actually in the lawnmower, so the batteries stay in there. It's got all kinds of cool features. The control panel is got whatever you need. It's got USB port, cruise control, place for your phone, great meter that tells you what's going on. So it's easy to use and very, very nice. I just mowed a couple days ago, and it'll be my wife's turn next time. So that's a little bit about what we did with the solar system out in the yard, and a little bit about how we use the system. One of the things I wanted to emphasize in this particular My Solar story was how doable this is. A lot of the other solar stories that we'll be talking about in this series are significant sort of heavy-duty operations that will take a contractor and some professional help. But this is really a doable kind of an arrangement. I snagged this image off of a company that I've used a lot, Northern Arizona Wind and Sun. And they sell these pre-set up kits, basically. And this is a very simple one that they sell. It's about $2,000. It includes a solar panel and some simple mounts for the panel. It includes the circuit breakers, circuit breaker box, batteries, wiring, charge controller, panel wiring, a great battery monitor so you know what the system is doing, and an excellent sine wave inverter. And it comes with good instructions. They have good support. It's something that you could, if you wanted to do this, order up and do yourself with just very minimal tools and learn a little bit about power. Because the inverter contains the plugs, the high voltage side, the only part of this that you deal with is the low voltage 12 volt side. And 12 volts DC is safe. You have no worries about the electrical safety of this. So it's a kind of a fun way to think about the possibilities of actually doing this yourself. Stick it on your SID and charge up your chainsaw. So that's, yeah, summary of what we've done, summary of how we use the electricity. And that's pretty much my 20 minutes worth of introduction. And I'd be happy to answer any questions if anybody wants to either comment about what they have done or ask questions about what we do here.
Yeah, Roger?
Yep.
I have a question. Is your sine wave inverter, is that modified or true sine wave inverter?
It's a true sine wave. It's actually literally a curved sine wave output.
Would it make any difference? The reason I asked that is because when I put mine in back in 2001, and it was then everything was off the grid, I did modified sine wave because it saved significant money and it didn't really impact the performance of the batteries or the
Sure.
the circuit. I don't know if that's where that fits in now, or true sine wave inverter is so cheap now that you really don't need to modify it anymore.
Ah, yes, right. Well, I guess I would answer that in two ways. The second, I think, is becoming true now. The true sine wave inverters are ubiquitous and relatively inexpensive. The modified sine wave inverters are still less expensive. And for all of the systems that I'm using here, a modified sine wave inverter would be fine. Everything here is easily capable of handling the sort of the stepped square wave of a modified sine wave inverter. But there are some applications where full sine wave is good. If you're going to plug in more sensitive computer equipment, I would invest in the sine wave.
Roger, I wonder if you or anyone else listening tonight has, in the spirit of a small solar, invested in solar-powered roof attic fans where the solar panels come mounted right on top of the fan.
I have not, but I've seen them, and I think it's a great idea.
I just said I put one on my rectory roof back in 2005, and it was great. So save on air conditioning costs in the summer, and in the winter it took moisture out. So, and it was probably the fastest payback outside of a solar, a heating pool, solar heating system for the pool that you can get in terms of a return on investment.
This is John. This is a silly question. You still have to oil the chainsaw, the chain itself, for your electric chainsaw?
Yes, you bet. Yep, I do. And I use steel bio oil, which is a biologically based oil. It's way more expensive than dinosaur oil, but it's the places that I use my chainsaw, I like it, and that's what I do. I bought it at a place here in town, Midwest Power, and they told me that I needed to buy 4 jugs of it because they couldn't sell it to anybody else. But anyway, yeah, I do oil it.
Roger, Terry Richards here. Do you think this system would be powerful enough for, say, an electric, recharging an electric bicycle?
Oh yeah, sure. In fact, we did that. My wife had a Pedigo for many years that she used to commute to MSU, and we charged it off this system for sure.
Yeah. Okay. Thank you.
The Pedigo specifically, the charger for it was well within the capability of the inverter. And this inverter puts out 15 amps of power, which is a typical house output. And with 4 big storage batteries, there's no problem with keeping enough power in there for the bike.
Thank you.
Roger, have you ever run into a situation where you just didn't have enough electricity stored in your batteries and you were using a lot of equipment and you just basically ran out of power from your solar system?
Only in the winter with the snowblower. The summer, it's no problem. I've never had that situation because I've only got a half an acre lawn, so the riding mower doesn't use very much of its capacity, and everything else is fine on a sunny day. Lots of power production for that purpose. In the winter, you get a long string of cloudy days, and the snowblower takes 2 big batteries. It takes a lot of power to run a snowblower. So I've had times when I was not able to recharge the snowblower batteries in time to use it again. So then I just plugged it into the wall outlet in the garage. But that's unusual. I mean, usually there's enough light somewhere.
So this is a completely independent system, and you didn't have to deal with either consumers or Lansing Board of Water and Light.
No, this is off. Yeah, it's off the grid. That's right. Yep. Yeah, it's off the grid by about 100 feet.
Hey, Roger, related to that, did you have to get any inspection done, or that's just not an issue from the township?
Well, before I put this system in, I investigated quite a bit with regard to permits. I checked out my zoning district, and I checked out requirements for towers, so to speak, and things like building and zoning or electrical permits to make sure that this was all within the what's referred to as a de minimis operation that doesn't need anything. As soon as you hook up to the utility, you have to take all that into account and do the interconnection permits and electrical permits and all that. But as an independent and small operation like this, the de minimis aspects of it didn't require extra on that part. But anyone doing this, you for sure want to check into all that first, including things like homeowners associations, because those can have some restrictive covenants for extra things in the yard and visual kinds of things.
Yeah, I know there can be height restrictions too for what you could do in your yard too.
There are, yep, for sure. Yep, if you're going to build something that looks like a fence, you got to have it less than 6 feet.
Roger, this is John Gorley. Does your tracker ever get confused if the sun is behind it, for example? Does it try to point the wrong way?
No, it doesn't get confused. There is a situation actually this time of year when the sun is behind it, just because of the orientation of the sun and the trees right now. I've not had it get confused, but I've had it when a period of clouds comes through in the midday, it can go to sleep for a while and just sit there and do nothing. And then when it wakes up, it's not pointed at the sun anymore. So it's not perfect as the sun gets in and out of clouds on a cloudy day. But on a typical day, like we had yesterday, for example, when it's sunny all day, it's very accurate. There's no confusion, tracks just right.
Roger, how much power do you store in those batteries? How many watt hours are?
These are 100 amp hour, 12 volt batteries. So they're 1200 watt hours each. And you can run them down to about 50% without damaging them. So they're storing about 600 watt hours for each battery, and I have 4. In my scenario here and the way that I use my system, I could comfortably get by with just 2 batteries because I'm not really needing to store all that much battery, but or much electricity. But these are left over actually from another project, and I mentioned they're getting kind of old. They came from another project that I had. I just put them in here because I had them. If I were doing it over again, I probably wouldn't use 4, but 4 times 600, I guess I've got 2,400 watt hours of power storage.
Now, do you think you'd use lead acid again, or would you switch to lithium chemistry?
Good question. I've been in conversation with Arizona Wind and Sun about getting a whole new set of lithium battle-born lithium batteries for my car charging system. And if I were to do this again, I would definitely go lithium. I think I mentioned that this company sells these sort of kits that are not pre-assembled, but pre-put together, and they sell them just with the lithium batteries now. In this case, the lithium iron. Let's see, lithium iron phosphate, LiFePO4.
Yes. Yeah, lithium iron phosphate. Yep.
Yeah. So that's it. That's what I would use for sure. Yep.
Now, what happens if the batteries get? What does the charge controller just shut down when the batteries get fully charged and you can't have any? Or where do you put the power then?
It's just wasted. Yes, the charge controller shuts down. It tapers off and then trickle charges the batteries for essentially ever. That's the situation most of the winter because I don't use the yard tools in the winter, and they just sit out there with the charge controller trickle charging them, keeping them at a float voltage all winter. Conversely, if they get discharged too much, it's the inverter that shuts down. The inverter has a low voltage shutdown on it to protect the batteries. And it just shuts down the system and turns off the AC output at a certain battery voltage to protect the batteries. So both the top end and the bottom end, the batteries are protected from either over or under charging, which is probably why they've lasted 8 years. I mean, that's a pretty long time for a good old lead acid battery to sit there and do its thing.
It's a nice system, Roger, and like I say, as you say, to get someone initially started in solar, that's a perfect way to go.
Yeah, it was actually fun for me, and putting this stuff together kind of kept up my encouragement and pushed me to do a few other things that are part of my other solar stories. And I do have a cabin in the Upper Peninsula that's completely off the grid, and that's a whole nother interesting story where we started out with wind power that didn't work. So we switched to solar there. So we've been off the grid up there since well, for almost 20 years now.
Why didn't it work?
The wind?
Yeah.
The wind turbines are not the small scale wind turbines are just not reliable in my experience. Now it's been a while, so I can't, I guess, speak for what's available now, but I used some good wind turbines back in the day, and they just didn't hold up. The yaw bearings wore out. The electrics couldn't handle the power. I just can't tell you the number of times I went up that tower to get that turbine off there to send it back to the factory. And I went through 3 turbines. And when they worked, it was fun. I mean, it was great to have the wind charging the batteries, and it was good. But boy, just reliability was nothing compared to solar.
Yeah, I think our toy is basically phasing out the wind aspect of his business, because I think the market's is moving away from small scale wind.
Yeah. I'm sure the large scale, commercial wind turbines are fine. There's probably some mechanical and electrical problems associated with those, but the small wind, for my purposes, just wasn't there, and it was too much of a hassle. So.
Now you stayed with 12 volts on all the off-grid systems, or Did you look at 24 or 48 volt systems too?
Both. The system that I use here in the garage to charge my electric vehicle is a 24 volts. I did that to reduce the amperage coming in and out of the batteries because it has a big power draw on that. And then my cabin system runs at 48 volts again for the amperage reductions. Because I've got some long wire runs up there where it would be really expensive to buy wire for 12 volts. That's a lot of amps in a 12 volt system. In the system on my cabin, I'm using 4.0 wire at 48 volts, and I can comfortably run a pretty high powered inverter there. But the system here at home for the yard tools that I just described is, it's a small inverter, no big deal. I've got some big wire going in there, but 12 volts works fine for that.
Well, I guess we're getting toward the end of our time. Any last question or two before we kind of adjourn?
This is my first solar story, and this has just been great. So I just want to thank John and Roger and everyone that joined us.
Yeah.
Yeah, I really enjoyed this. Thanks very much.
Yes.
Yeah, cool.
Thank you, Roger. Really.
We've got another one coming up.
Yeah, we've got them scheduled through June, and I'm starting to schedule into July. So I'll be sending out notices on a weekly basis. The notice first comes out on Monday, and then a reminder on Thursday. So hey, thanks for everybody for coming tonight, and stay safe and stay well. Take care.
Okay. Thank you, John, very much.
Thanks, John.
Bye-bye, everybody.
Yep.
Bye-bye.
Thank you.
Thanks.